this session we can deal with distributed databases. We are very familiar with different database architectures like parallel databases, distributed databases, centralized architecture and client server architecture. Here in this session I am going to discuss about distributed databases. Before coming to what is distributed databases, we can deal with what is a distributed system. In a distributed system, data are spread over multiple machines. They are known as sites or nodes. They are connected through some interconnection network and data can be shared among these machines. Now coming to a distributed database system, it consists of a set of loosely coupled sites, and they are by means a loosely coupled site, we are saying there is no memory sharing, or we can say they are not sharing any physical component. The database may be residing in different sites, and transaction may access data that are residing on different sites. There are two different categories of distributed databases. They are homogeneous and heterogeneous distributed databases. Now coming to what is a homogeneous distributed database. In this type of distribution, all the sites have identical platform, or we can say all the sites share the same operating system, or we can say all the sites use the same operating system, same database management software, and they use similar schema. And each of the sites are aware of the other site. And in this particular distribution, we can say the flexibility is that it is very easy to manage because they are using the same kind of platform, so there is no need for any query translation. Now in case of a heterogeneous distributed database, all the sites may use dissimilar platforms. That means the underlying operating system or the database management system software or the schemas may be very different, and the sites are unaware of the other sites participating in the distribution. Here we can say the complexity lies that the schemas are different in different sites, so there need some kind of query translation, and also the underlying software and the operating system are different, so there should be some extra care taken for managing the concurrent execution of the transaction. The translations are required to undergo this particular concurrent control mechanisms. Now we can deal with how the data is stored in distributed environment. There are two ways for distributed data storage. One is replication and the other is fragmentation. In case of replication, the system maintains multiple copies of the data that are stored in different sites. In case of fragmentation, the relations are partitioned into several fragments which can be stored in different sites. Sometimes there may be the need for replicating the fragmentations also. Now coming to the replication itself. Okay, in data replication, a relation is fragmented a relation or fragment of a relation is replicated in different sites. A full replication of a relation may be done where all the participating sites store the same relation. We would say it as a full replicated copy. Okay. Now coming to the fragmentation. We can deal with the advantages of replication. Main advantage is availability and increased parallelism. In case of failure for a participating site, the other sites contains a copy of the database, so that can be shared by all running sites. And in case of parallelism, the queries can be parallelly executed because the same relation R is duplicated in multiple sites. Also, it causes very reduced data transfer because the required data are stored in multiple sites, so data transfer can also be reduced. But still, there are certain kind of disadvantages for replication, that says there are increased costs on updates because in each update, each replica of the relation R must be properly updated. And also in case of the controlling the concurrency, there should be special mechanism so that all the replicas are used in a concurrent or accessed in a concurrent manner. One solution for controlling this is to use a primary copy. or we say one of the sites that stores a copy is treated as a primary site, and that copy of the database is treated as a primary copy, and the concurrency control mechanism should ensure that the primary copy is properly updated. Now coming to the data fragmentation. Here the relation R is fragmented into different subsets. There are two possibilities. One is a horizontal fragmentation and the other is a vertical fragmentation. In case of horizontal fragmentation, the relation is splitted by tuples or rows. That is, a relation is splitted by taking some consideration to rows. For example, if in case of a banking environment, we can say a particular range of account numbers are stored in one site, the others are stored in another site, and so on so. In case of vertical fragmentation, the schema is splitted, or we can say the columns are splitted. The subset of the schemas are stored in different sites. For example, the relevant columns of a particular relation can be stored in different sites. For example, if in an accounting schema, suppose accounting number and branch name and details are or more concerned in one site, that can be stored in that site, and the account number and the balance information, if that is concerned of another site, that can be stored in another one. And the advantages of fragmentation are, as in the case of a replication also, it allows increased parallel processing because the fragments are stored in different sites that can be accessed concurrently. In both horizontal and vertical fragmentation, it allows an increased access for the data set. Okay. Even though there should be some care taken so that the user may not be aware of where and how the data are duplicated or fragmented. This concern deals with the concept data transparency. That says a user in a distributed environment should not be aware of the details of how and where the data items are stored. This leads to three kinds of transparency. That is fragmentation transparency, which says where and how the fragments are done, or where a particular fragment is stored. In case of a replication transparency, it says the user should not be aware of how many replicas are there or where the replicas are stored. And another one, the location transparency, it says the user should not be aware of where a particular data item is particularly stored. Now another main topic in distributed database is regarding distributed transactions and commit protocols. First of all, we can deal with what are the peculiarities for distributed transactions. In case of a distributed environment, there are two types of transaction. One is a local transaction and the other is a global transaction. A local transaction is the one which accesses and updates data only in a local site, and a global transaction is the one which can access and possibly update data in several sites. And again, each site has a local transaction manager and a transaction coordinator. The responsibility for a transaction manager is to ensure the ASIC properties of transactions that are executing at that particular site. And another responsibility is to create or make or update a log for a recovery purpose later. Again, the transaction manager should coordinate all the concurrent execution of transactions that are executing at that site. Now, regarding the duties of a transaction coordinator, the coordinator should initiate execution of a transaction that originates at that site. And again, the coordinator is responsible for distributing the sub-transaction. That means if a transaction is a bigger one, the coordinator should split the transaction into sub-transaction and that should be delivered to appropriate sites. Again, the coordinator should coordinate the termination of a transaction that are originated at that particular site. That means the outcome of the execution of the transaction should be noted by the coordinator, that is whether it is properly committed or aborted. And we can see the action or the relation of the transaction coordinator with the transaction manager in the figure. There are different sites. Say we are saying that is computer 1 at site 1 and etc. up to computer n at site n. Each of the transaction coordinator are interacting with the transaction managers in the other sites for ensuring all of these properties. Okay. Now, we have to deal with what are the different failure modes that can be occurred in distributed environment. Mainly we classify the failures in a distributed environment by, one is the failure of a site, and another is a loss of message, and another is the failure in a communication link, and a failure in a network partition. A failure or a loss of a message, that should be handled by the network transmission control protocol like the TCP/IP. And communication link failure can be handled by using protocols or by routing the messages through some alternative link. The partition, or we can say a network partition occurs when we split the sites into subsystems, and if there is a lack in connection between them, we would say there is a network partition error. Now we can think about commit protocols used in distributed databases. The commit protocols are used to ensure atomicity across different sites. A transaction which executes at multiple sites must either be committed at all sites or aborted at all sites. We have seen that it is a basic property of atomicity. It is not acceptable to have a transaction committed at one site and it is aborted at another one. There are two kinds of commit protocols used in distributed environment, that is a two-phase commit protocol and another a three-phase commit protocol. Two-phase commit protocol is the widely used one, and three-phase commit protocol, it overcomes certain problems with the two-phase commit protocol. Now we can deal with the two-phase commit protocol. Execution of this particular protocol is initiated by the coordinator after the last step of the transaction has been executed. And the protocol involves all the participating sites at which the transaction is executed. Now we can consider how this particular protocol execution is going on. Let T be a transaction that is initiated at site, say SI, and let the transaction coordinator at the site SI be CI. When the transaction T completes its execution, that is when all the sites at which T has executed informs the coordinator CI that T has completed, then the coordinator CI starts the 2PC protocol. There are two phases. In phase 1, it obtains a decision regarding what should be done for the execution of the transaction. Here, the coordinator asks all participant sites to prepare for a commit for the transaction T. For this, the coordinator CI adds a record prepare T to the log, and the log is forced onto the stable storage. And again, it sends a prepare T message to all the participating site at which the particular transaction T is executed. Now, upon receiving the message from the coordinator, the transaction manager at the site determines if it can be committed, whether it is possible to commit the transaction there. If not, it adds a record no T to the log in its site and sends an abort T message to the coordinator CI. If the transaction can be committed, then it records a ready T to the log and then forces all the records for the stable storage and sends a ready T message to the coordinator CI. Now, in phase 2, here the coordinator records what should be done or what decision should be taken for the execution of the transaction. Here, T can be committed if the coordinator CI received a ready T message from all the participating sites. Otherwise, T should be aborted. The coordinator adds a decision record that either commit T or abort T to its log, and the log is forced to the stable storage. The coordinator sends a message to each participant site informing the decision about whether it is committed or aborted. The participant sites should take appropriate actions locally. Now we have to see, we have seen there are different failures that can occur in distributed environment. Now we have to see how different kinds of failures are treated by this 2PC protocol. First of all, we can see how a site failure is handled by the coordinator. If the coordinator CI detects that sites one of the site is failed before responding with a ready T, then the abort T is assumed. Otherwise, the rest of the protocol or the 2PC protocol is executed in the normal fashion. When the failed site, say SK, it recovers, it examines its log to determine the fate of the transaction that was active at the time of its failure. If the log record of the site SK contains a commit T, then the site executes a redo T because it was promising to commit the transaction, so whatever has been done by the transaction should be redone. But if the log contains an abort T record, then that says there was some error, so the site should execute an undo T because all the effects done by the transaction should be neutralized. Now, suppose the log contains a ready T, then that says the site should consult the coordinator to determine the fate of transaction T. If T was committed or the coordinator has notified that T was committed, then the site should redo T and should write a commit T record in its local storage. And in other case, suppose that was an abort, then the transaction should be aborted and a log record undo T should be forced to its stable storage. Suppose the log contains no log record concerning the execution of the transaction T. That implies that the site SK was failed before responding to a prepare T message from the coordinator. Then the coordinator must abort the transaction T and SK must execute an undo T. Now we have to think of what should be done in case of the failure of a coordinator. Suppose the coordinator fails in the midst of the execution of the commit protocol, 2PC protocol, then the participating sites must declare the fate of T. That is, in some cases it may be unable to make a decision by the participating site. We can see it later. In such case, the site should wait for the recovery of the failed coordinator. Suppose an active site contains a commit T record in that log, or we can say in the log record of its local stable storage, then the transaction T must be committed. But if an active site contains an abort T record in its log, then T must be aborted there. And if some active site doesn't contain a ready T, rather than waiting for the coordinator CI to be recovered, it can be preferably aborted, or we can say it is very good to abort the transaction T there. If none of the preceding cases holds, then all the active sites must have a ready T record in their log, but no additional control records are received by the coordinator. In that case, the sites should wait for a recovery from the coordinator. Now coming to the failure of network partition. There are when a network partition fails, we can say there are two possibilities. One is that the coordinator and all the participants remain in one partition, in the single network partition. In that case, the failure has no effect on the commit protocol. But in some case, the coordinator and some of the participants belong to one network partition and some remaining sites may be in another partition. In that case, the sites that are not in the partition containing the coordinator should simply execute the protocol to deal with the failure by assuming a failure of the coordinator. We have seen that before. But in the other case, or we can say in the other partition, that is sites that are not in the same partition as in the coordinator, it should follow usual commit protocol assuming a site failure that we have discussed earlier. Now, there are certain problems with the two-phase commit. Suppose the sites wait for CI2, the controller, or we can say the transaction coordinator CI to recover. As the fate of T remains in doubt, T may continue to hold the system resources because the sites are waiting for the recovery of the coordinator, but the fate of the transaction is not clear now. In that case, the transaction would continue to hold all the system resources For example, if it is using a locking protocol, the transaction may grab maybe, or we can say the transaction may have grabbed all the locks, still the transaction may be forced to continue to hold all the locks. And also this situation is undesirable because other transaction may be forced to wait for completion of T, and data items may be unavailable not only for the failed site but in the active site as well. So this situation is called a blocking problem because T is blocked pending the recovery of the coordinator Ci. Now we have to deal with the other protocol, that is the 3-phase commit protocol. We have seen there are drawbacks in 2PC protocol, that is a blocking problem. In 3-phase commit protocol, this blocking problem is resolved. But the 3-phase commit protocol, it uses certain kind of assumptions. One assumption is that there is no network partitioning, and another one, it assumes that at any point at least one site must be up, and the third one is it assumes at the most k sites can fail, that is less than k sites can only fail. In phase 1, it obtains the preliminary decision as in the case of a 2-phase. That means the phase 1 of 3PC and 2PC are similar. Here also every site that is ready to commit if it is instructed by the coordinator to do so. In phase 2, the 2PC is split into 2 phases, phase 2 and phase 3 of 3PC. In phase 2, the coordinator makes a decision as in 2PC, and this particular phase is called, the second phase is called the pre-commit decision phase, and it records it in multiple. That means the decision is recorded at multiple sites, preferably at least k sites. In phase 3, the coordinator sends a commit or abort message to all the participating sites. Under 3PC, the knowledge of pre-commit decision can be used to commit despite the coordinator failure, because in the second phase we have seen that the particular decision is sent to more than or at least k sites. So in case of a coordinator failure, the decisions can be grabbed from some other site where the coordinator is not residing. But the drawback of the 3PC is that even if it avoids a blocking problem, there are higher overheads, and also the assumptions used in 3PC cannot be satisfied in real practice.